Hello everyone. Can you hear me? I'm just looking into the chat. Yes, I have a chat in front of me to make sure that everyone is getting me properly. Okay, so nice. Thank you very much for being with me today. And I will share my screen. Maybe we'll just wait a few minutes so that different people can connect, and I will share my screen and then start this webinar. Okay, so I will click on share and yeah. Okay, so normally you should be able to see my screen by now, and I'm moving to the white mode. So welcome everyone to this session, and the topic of today it is yes, this is pretty much like the longest topic maybe that we shared with you guys, but we'll talk about it's kind of a gentle introduction to what is called LLMOps, and talking a bit about LLM design patterns, because when we want to kind of create and build application based on MLOps on LLM basically, we will use basically LLMOps, and I will try to be more specific and when we will discuss about it in few minutes. And while we are waiting, maybe we will just start. I will start by introducing myself. I'm Sebastian. I am a machine learning engineer at DataScientest. Yeah, I've been at DataScientest for a few years now, and I work a lot on the MLOps product, basically the MLOps trainings program. And yes, when we are starting basically to building maybe the next product that would be more focused on LLMOps also. But generally, more than that, as you maybe have seen few of my previous webinar, I'm really passionate about AI, and especially today's where we have LLMs that comes into the picture. And as you have maybe understood by now, this webinar will be in English, so I hope that we're prepared to that. And yeah, and yes, the English is not my primary language, so this is probably get error here and there, but the most important thing, I will try to be as clear as I can. And of course, you have the chat. I have the chat in front of me. Don't hesitate to ask any question if you find it, if you want to, basically. Okay, now a bit more, a word or two about DataScientest itself, because maybe you are already working in one of our training. But if you don't know about DataScientest, I will kind of present DataScientest in few slides. This is just to give the general idea. Just bear with me if you already know DataScientest, and if you don't know yet DataScientest, this will be the perfect opportunity to see what it is. So in DataScientest is basically we can call it like a brand basically, and it is cool as well, of course. And like the name suggests, DataScientest is more focused on data related skills and jobs basically. So we are training on most data related jobs out there. And we have two other schools, which are Dev University and Cyber University. And once again, as the name suggests, Dev University is more focused on jobs around, I would say, development, like full stack engineer or stuff like this. While like the name suggests, a cyber university is more focused on cyber security and skills and jobs around this discipline. But generally, the all the experts basically can operate over the different schools basically, and we have experts more specialized on data related stuff, like myself included, and I have some other colleagues that are more, I would say, versed into development, front end, or full stack application, and other that are more focused on cybersecurity as well. So we have a lot of training. Of course, we deliver our training in bootcamp in continuous and or alternating format. So bootcamp is rather intense. In 3 months, basically, we want to give you the most of our knowledge, basically, and continuous is a bit longer than that. We are also providing our courses, of course, internationally. So not specifically in France, but more broadly in the United States or yes, internationally speaking. And of course, we do our best basically to keep our content constantly updated to make sure that we maintain basically the satisfaction rate basically of our students. Okay, so just the last slide about the DataScientest. We are not working alone. We are working with a certified organism to make sure that we are delivering highly standard, basically technology and with a good pedagogical approach. So most of our partner basically are there to certify our training to make sure that pedagogically speaking it is okay and that it answer basically a market need basically. And of course we are also partnership with major cloud provider like AWS, Microsoft, and GCP to train people to like get prepared to certification, but also to just train people on how to basically use the different cloud services as well. And we are not only working with a certification organism or cloud provider, but also with companies that want to train the employee basically to get in touch with the trending technologies and making sure that they are not lagging basically, and they will have the possibility to adapt very quickly to trending technology, I would say. So this is a word or two about DataScientest. Now, moving back to today's topic, as I suggested earlier, the topic of today, it is talking about a very gentle introduction to LLMOps and talking about LLM design. So this will suggest that maybe not everyone will be like really interested in this, but I prefer to be frank like from the start. To get the most of whatever I will discuss with you today, you need to have a pretty much good idea about what is an LLM, and maybe you already tried on your own to use an API an LLM API like the OpenAI one or the Anthropic one, and maybe you already are used to do what is called nowadays prompt engineering. So you already know that you are when working with LLM, we will use prompt basically to guide the model to deliver highly improved answer. So I built this content for maybe if you are a software engineer interested in LLMs and you want to know a bit how to adapt basically your knowledge to the creation of LLM-powered application. Or maybe you are a machine learning engineer yourself, transitioning to the LLM development because maybe in your company you are starting thinking about how to use basically LLM in your use cases. Of course, I won't cover all of the use cases. There are different use cases. I will simply just give general and like good practice. Of course, in your own company, you will have to build on this. And or maybe you are a technical lead and you simply want to explore a bit how can we actually build a product based on the AI. So this will mean basically integrating AI into maybe a solution that you already have. And of course, if you are a trainer like myself and you want to know basically if you are interested in AI powered learning tools, because nowadays basically we are all actually including the AI into the loop because AI can just very much more adapt basically to public compared to like a classic training. You're supposed to have some technical understanding basically of LLM and maybe start experiencing your. And of course, if you have done basically the MLOps training that we provide, this also or if you have even have a data engineering background, this also will be interesting for you. Okay, so this is I just wanted to from the start directly talk about the target audience here, and now about the topic. Of course, we will talk about LLMOps. I will try to introduce where it comes from, what it is, the methodology when we are doing LLMOps, and the difference between LLMOps and MLOps. And I will talk about LLM design patterns because, of course, we are not kind of building from scratch always. We will use basically common methodology, common best practices, and LLM design patterns that already are out there to guide us when we are building an application based on LLM. And to prepare you to introduce kind of the demonstration that that I will present you, I will talk about agent. What are agent? We hear a lot about agents nowadays, so I will try to very simply explain what an agent is and present you a framework like very rapidly a framework which is called LangGraph by the creator of LangChain, the famous LangChain that is used basically, which is a good and well established framework basically when we want to uh, uh, create an LLM based application. And after that, of course, I will have to do a short demonstration to give you to I will try to go from a broader idea of an application until basically the component and the code itself. Of course, I've already prepared this. I won't bother you with details. It just is I just want to focus on the transition, not on basically the actual implementation of each component. And we will finalize with by a Q&A session. So that's the agenda of today. Lot of things. Of course, I could have divided this into separated webinar, but I always want to kind of give the maximum in a short amount of time. I know that we don't have like huge amount of time, but I will try on my I will try my best. Okay, so let's start by introducing LLMOps and just know a bit about where it comes from. And of course, I have the chat in front of me. If you have a question, you can just send your question, and I will try to read your question while I'm presenting and try to answer it. Okay, so first of all, just to give like a broader view about just being more specific about maybe I will change the place of my yes not this one, not this one, and sorry. Okay, maybe this is better. Okay, so before talking specifically about LLMOps, the idea here is to present where it comes, where we were basically, where we come from, and where we are at today. So on the picture here, you can see that we started working with traditional machine learning basically, and we evolved basically by using foundation model very recently. I mean, in almost 5 years, basically, we have today's really powerful and open source model that we can even deploy on our own and leverage the power of these tools. And as well, we are as I'm talking today, we are almost basically in the agent area where basically we won't simply use like a bare a very simple LLM, but we will leverage basically the agentic capabilities basically of an application in order to move forward. So this is I just wanted with this slide to point out there has been a very rapid change since 2020 basically, and since this year basically the arrival of LLM basically into the businesses have changed almost everything. So LLM are becoming like the core building blocks of any software basically because we talk about I don't know even like um, I forgot the name of the there are lots of different solutions that include LLM. Even in phone right now, you have today the new phones that are coming on the market are using LLM maybe to enhance the visual aspect of video or photo or automate tasks. And yes, LLMs are just out there nowadays. And of course we cannot just we cannot do like the LLM doesn't exist. We have to basically find a way basically to understand how to use them, how to use them. um so yes, generative AI is not just a trend, so it's a well established basically technology that is here and for very long. It's a foundational shift that are reshaping basically the productivity, because we are moving way more faster than like in previous years ago, when we want to create something from scratch, or when we want to refactor, let's say, technology, or even, I don't know, something. Today we can use basically LLM to move a bit faster. And um, I will share with you the slide later, and I will include some archive study here that point that there will be basically a 1.5 trillion of impact market based on the gain in terms of productivity basically that we will gain from using basically LLM. And of course, I'm talking about productivity. So more and more company include the use of LLM in their workflows to be more faster, to deliver, I will say, maybe more advanced services and product to the client, and to enhance also the quality of the answers as well. So um, as the time pass, basically more and more company, even trading company like DataScientest, we are interested, of course, in including basically AI into the workflow to a bit more faster and enhance basically the quality of what we are delivering. And of course, for this impact, this will also impact developer as well, because of course we have nowadays lots of different technology that we can use to as code assistant basically. And we have the world famous GitHub Copilot, but based on the Copilot, we have today nowadays a lot of different AI assistant agent basically that are already embedded into our programming environment, and we can simply just leverage these model to once again code a bit more faster, and maybe onboard on an existing technology a bit more faster as well. Because one of the challenge when you are a software developer, when you are not developing your own solution from scratch and you just came into a company, you will get access to a code base, and sometimes without LLM you will take a significant amount of time understanding the code bases, the code rule, etc., etc. And nowadays with the, let's say, GitHub Copilot, you will simply clone the repository, open it, chat with the model to understand how the code is structured, what the code does, etc. And you can even start programming and updating some functions or classes without having to take too much time understanding basically the different components. So this maybe had a more and more impact. And yeah, when we are not starting from scratch nowadays, I will say, unless you want to do it from scratch. But nowadays you can have a very simple boilerplate very easily that you can iterate on very efficiently using these technologies. So we are entering basically a brave new world, because this completely changed the way we are building application, the way we are writing the code. And of course, this is for the better and a bit for the worse at the same time. This depends on your point of view. The better because um, the entry level to IT basically have been lowered by the use of this technology. But of course, we cannot simply just use this technology without thinking. So we need to, at the same time, pay attention to what the technology is doing basically, and make sure that we understand it properly before basically moving faster on that. So this was simply to kind of give the general context here. Before we were kind of working without it, and everything has to be kind of starting from scratch. And we were iterating. Of course, we worked in team, but this could having going from an idea to a product on the market could take a significant amount of time. With the LLM now, and companies that start to use it, we are kind of moving a bit more faster, and this is really interesting, of course. So as we are moving beyond experimentation, because nowadays we are no more experimenting, because LLM is there for very long and we don't have choice. We simply need to master how to use it. So we need basically robust practices for deploying, monitoring, and iterating using LLM power, using application that use basically LLM. And this is basically the purpose of this presentation here, is to, we know that LLM is there. So what is the methodology, and what do we need to basically know, basically, when we want to create application based on that. Okay, so just a rapid like broad view once again about where the history basically and what we have today. We had previously to create a machine learning model to answer specific needs. Basically, we were rather focused on the model itself, trying to build a model that performed a very specific action, like, I don't know, predicting the weather or answering yes or no. And of course, not all the company were using machine learning, but as the data increased, machine learning started to be really interesting to use within each company to uh, um, take action based basically on prediction of this model. And with the amount of data that were growing, we started using lots and lots of deep learning modelization, meaning deep learning are really powerful when you have huge amount of data and you don't have basically time to on your own create the different targets and the different features, etc. If we can view deep learning basically as a automatic feature engineering on data based on huge amount of data. And of course, we will work on the architectures of this deep learning model. We had to choose wisely which architecture for which task. But basically, with the amount of data, we needed more robust and automatic approach. So we moved to like a rather model-centric approach to a rather data-centric approach, because the architecture was kind of already there. We simply need to select the proper one and tweak it a bit to make sure that we have the highest performance possible. And based on the success of deep learning, came basically the foundation model. So foundation model are what unlocked basically everything that we know today. Foundation model are deep learning model with transformer architecture and train on huge amounts of data. So we started talking about large language model after the creation of foundation model. And nowadays, basically, we are more focused on building application based on foundation model. So there are a lot, yeah, lot of different use cases when we don't basically need to create a model ourselves, and before starting to wrap this model inside a complete solution. We simply need to nowadays to find the model that is best suited for our need, basically, and then just I would say deploy this model through an API and use it as we see fit. So we moved from rather specialized basically area where we needed some data scientists that will get data, train model, create the package the model, etc., and then machine learning engineer that will then build an application around that, to a rather focus more on, oh, I want to build my application. Which model do I want to need? Okay, of course, we need to create this software, this application, this architecture, but we will not take too much time. We will not always take too much time, depending on what we need, on building the model directly. So nowadays we are basically more focused on LLM application. So we will simply combine pre-trained model that already exist. If you go over the Hugging Face model page, you will see a huge list of different LLM that you can just try out and pick one. These models are freely open, so you can simply download the model, run it on a private server somewhere, and address your need with that. So you don't even specifically need to pay for basically the model. You simply need to find out the model, download it, and use it. And so since the model is kind of really easy to find, we will the shift have been basically to be a bit more focused on the architecture itself. So we already know that the model is there, and we simply need to embed this model in a robust architecture to make sure that the system is working efficiently. So the impact of the LLM on specifically the software development phases, while this is like huge advantage that LLM brings into the picture. The LLM enable the LLM unlock innovative software solution because um, when we were working on classic software engineering, basically we uh, took a lot of a huge amount of time finding the rule, then coding the rule, and then packaging the rule inside a complete software. And nowadays we will kind of leave the finding the rule to the model, which has this broad general knowledge, and this unlock innovative aspect as well, because sometimes the uh, general knowledge of the model will kind of give us even idea about what we might do with it. We will, of course, since we need to create an application around the model, there are well-established patterns nowadays. We cannot just build your application the way you want. There are best practices out there that, and we will simply pick and select the right pattern for the use case that we have in order to create our application. Since the model has a broad knowledge, we will leverage the complex reasoning basically of LLM basically to have something which is at the same time really easy to create, but can reproduce or recreate really complex way of thinking, I will say. And of course, I mentioned earlier that by using LLM, this lowered the entry level. So this means that you can, in a matter of hours or even days, prototype a complete full stack application if you simply know how to prompt nowadays. And you have lots of different technologies that are out there. I can simply cite some of them like V0, Bolt. There are lots of different other technology like this. Lovable, this is another one, and you can simply prompt your ID and have a prototype that is ready in a matter of seconds, and you can even deploy it by simply clicking on a button. So the prototyping is very more efficient nowadays. So the use of LLM need to use a new paradigms. We cannot keep being, I will say, classic, because the LLMs have some probabilistic behavior. Of course, they are really powerful. They have a huge knowledge about a lot of different things, but since the output of the LLM is probabilistic, we cannot, for sure, I will say, master the way the model will provide an answer. So we need to kind of handle this probabilistic behavior by adapting a bit, basically, some practice that we will take from the classic software engineering patterns. But we have some differences because, for example, here, um, classic software is more, I will say, structured. We will create the code, embed everything in clear structure, try to master the behavior by coding the rules of the orchestration rule, I would say. And with LLM, since the LLM has the possibility basically to, I will say, think and reflect and adapt, I will say, we are more working in an input-output pattern. Like we will provide an input and decide to work on an output of the model. We have model that thinks nowadays, so this means that we can try to do more complex things using the LLM and leaving the LLM basically finding the rules to answer a specific need. We can connect LLM to tools basically so that the LLM will know not only think but also decide whether or not to use basically a tools. And of course, this is kind of handled by the LLM itself, and we will simply try to minimize basically the uncertainties of this output basically, but we cannot avoid handling these probabilistic effects. So we are moving from basically predictable of the classic software pattern to possible, because yeah, we are talking about probability here. So it is really challenging basically to have the exact I would say even behavior or answer. We will try to minimize this, but there will always be some minor changes, even if basically the general idea or the general methodology remain the same. So LLM needs patterns that handle uncertainty while maintaining reliability. So we want to minimize the probabilistic effect while actually keeping the flexibility that comes with using LLMs. Okay, so in terms of patterns, if I just try to kind of create the three main categories that I see out there. Of course, we will go a bit into much more detail later, but this I just wanted to give you like the general category of patterns of methodology that we will have out there. You have the input-output pattern. So we will use this basically to simply interact with the model to do something. We have the tool pattern where using our architecture, we will leverage the use of different tools. Think of a tool like a specific environment where an execution will be made. It could be a database, it could be a simple terminal, it could be a web search. So you will simply kind of include different tools in your architecture and let the model basically decide which tool is best according to a specific question. And you have the thinking pattern where this is more for more complex logic basically that you don't want to code yourself, and you will basically maybe in the process the model will need basically to um, have a step-by-step approach while reasoning on its own. So we will simply kind of create an architecture that will enable basically a thinking pattern. So this is the three most basically paradigm that you will see here in terms of architecture. And basically, when you are working with LLM, you will simply when you are designing an application based on LLM, you will simply have to think about the block that you need. Basically, this is why I've talked about Lego here. It's because the patterns are already there. And of course, these patterns are not mutually exclusive. This means that you can combine them as you see fit. These are simply the different, I will say, block that you have, and you will simply decide that okay, in my architecture, I need an input output. Then I will use a thinking output, or maybe use a different behavior. You will compose basically your blocks based on the desired output that you want to use. And this is where LLMOps come into play. Um, um, I've written here that LLMOps built on MLOps. So this means that okay, LLMOps is not something different. This is why I mentioned that it's not a revolution; it is an evolution, basically. We use best practices of MLOps, but we adapt it to, as I mentioned earlier, the probabilistic behavior of LLM in order to keep basically the output the same. So we build on MLOps principle, and we adapt basically to challenges of large language model. And we are moving from model to interaction, because basically when an LLM works, basically it will interact with a lot, either with tool or with, I don't know, the end user. And we are kind of more shifting to a more interactive approach in order, of course, to to constantly adapt basically to what is required. So this is why in the LLMOps you will include basically the MLOps principle, adapt for large language. So you will make some adaptation of MLOps to the probabilistic behavior. And since we are working with something probabilistic, we always need a human in the loop to make sure that we are not going off guard and creating or doing something very wrong. So we will include human system interaction with the client or with the designer in order to kind of harness basically the power of the LLM itself. So LLM ops, ML ops is for machine learning operation. And when we are doing ML ops, we are basically more want to manage basically the life cycle of a model. And when we are talking about model, it could be a machine learning model or a deep learning model. And when we are doing LLM ops, basically, of course, we retrieve the model, but the model is more powerful since it is LLM that we are using, and we simply will pick up basically few practices from the MLOps and adapt them basically to be more efficient with LLM. This is basically the continuous improvement cycle. So we keep the cycling approach of the MLOps, for example. And here I have you have the main phases when you will have to design an application, when you have to do LLM ops. Basically, you will design, develop, deploy, monitor, and iterate each time. So, and basically, when you are doing LLM ops, you will have to manage key component like prompt engineering. This is will be the very bare minimum that you will use. Of course, I mentioned pattern, so you will pick up the pattern that are best suited for your need, and you simply embed this pattern into your architecture. Quality evaluation is really important because before deploying, we will be a bit more intense in terms of evaluation to make sure that we are not simply deploying a model that can do a catastrophe somewhere. We will monitor the response of the model. So we keep track not only of technical metrics, but also on interactions basically with the end user. And of course, we will establish a more robust feedback loop in order to make sure that we can rapidly change something when we are detecting some shifts here. So we are keeping the cycling methodology. LLMOps introduce new way to measure success, including behavior testing and human feedback. So we are no more, I will say, simply monitoring, let's say, the performance of the model or the drift of the data, etc. But we will also make sure that the interaction goes smoothly. The answer provided is I will say, professional answer, and try to master basically the way the model is interacting with the end client. So we have way more testing phase when we are working in LLMOps. So a structured LLMOps approach helps bridge the gap between experiment AI and reliable production. So of course, when you will prototype your application, you will kind of have a minimum testing evaluation step, but the real difference, like a really huge difference, will be when you will need to put into production these applications that use your LLM. So this is much more intense than the simple MLOps phase. So LLMOps focus on prompt design and orchestration, while MLOps focus on model training and deployment. So we will train a model, a deep learning or a machine learning model, and decide to deploy it or not. LLM ensure reliable AI behavior. So through LLMOps methodology, we want to kind of master or frame the behavior of the model, because the model can go in lots of different directions. And of course, complex reasoning flows, because when the task that we want to kind of address requires some deep analysis, of course, this is where LLMs will shine, because we will use basically LLM that have these capabilities basically to understand basically with codes on its own, and then adapt without being programmatically told to do the same thing. Okay, so this was to introduce what is the difference, what is MLOps on its own. So when we are talking about MLOps, we have some classic machine learning or deep learning, and we simply want to manage the life cycle of the model. And of course, we will have to have some data pipeline, testing phase, etc. But we are more kind of uh, broadly, we are saying that MLOps is like DevOps, but with machine learning consideration in the loop, like handling the data, handling the model, and handling the code at the same time. With LLM ops, of course, we don't have always basically to train a model. We can simply leverage an existing model, but since this model has these capabilities of changing the behavior, we'll have to basically master frame basically the way the model can behave and interact basically with the other component of the architecture. So now LLM ops methodology in practice. So the question here is, how do we do it in practice? I already mentioned these steps here. You have the design phase, you have the deployment, the development, deployment, monitoring, and iteration. So these are the main steps basically that you will follow. At the design step, for example, you will have to properly understand and frame your use case, select the LLM that will be used, basically, because not every type of LLM are suited for your need. If you want simply to do some, I don't know, sentiment analysis, you will not use, for example, you can do it, but it will not be efficient to use a model like O1, for example, for that. You can use a much more simpler model to do some simple classification if you want to do it. So you, based on the use case that you framed, basically, you will try to find out the model which is best suited. Then you will to since this model will not live on its own, you will need to have some interaction around your model. You will need to think about the pattern that you need to establish in order for your interaction to go smoothly. And maybe you will have also to prepare some data as well. This depends if you want later in the development stage to fine tune your model, or maybe, but this is not mandatory at all if you start from scratch. If you start from scratch and you don't have prior interaction with some client, you can start using an LLM only with prompt engineering, and then through the feedback loop, save some data that you will use later on to fine tune your model. So this is the design phase. Now you will move to the development phase. And in the development phase, you will, of course, always, it is recommended to start with prompt engineering and to push the prompt engineering to its maximum until the moment where you see that, okay, prompt engineering is not enough because I've tried a lot of techniques, etc., and I don't have the exact behavior that I want. So maybe at this point you will decide to rather fine tune your model. But this will come with some limitation. But of course, this is the moment where you start thinking about kind of adapting your model. So based on the prompt engineering, you will implement it. So interact, use the API of your preferred model, and then try out different prompts, different techniques, etc. And then, of course, while you are implementing, when you are developing, you will test and evaluate basically the behavior of your model at the same time as the performance metrics to make sure to detect if the model is efficient enough and if the model has the right behavior, the right answers. Let's say that at the end of the development, everything is okay for you. You have created your, I don't know, your level 6 prompt engineering, your level 6 prompt, everything works smoothly. You will then go move to the deployment phase. And when we start thinking about deployment phase, you will retrieve MLOps basically technologies, I will say. So I'm talking about containerization here to create microservice architecture. You will need to set up some infrastructure somewhere, set up a server, for example. You will have to think about a lot of different things like the scaling strategy. When I'm talking about scaling strategy, the idea is how will you deliver the same service, the same level of service with huge amount of people and adapt it as you have client basically. So scaling strategy and security measure. So since we are using model, we have new threats that come with the use of LLM. So how do we make sure that we are doing it properly? So this is I would say this is production consideration around basically the model itself. So this will require basically the selection of specific tools that we will embed inside a complete architecture. And then the final thing that we always do before, I will say, clicking on the go live button is the monitoring. So we need an active monitoring, a constant active monitoring, detect a lot of different things. We will we will keep track of the drift of the data itself, because the way the data that is provided to our model, to our architecture, will change with time. So we need to detect it proactively. Of course, we will gather performance metrics. So we will do a classic monitoring stuff, and we will get feedback from our user and from the environment where the software is running. And of course, we will also perform behavior tracking to kind of not only track the behavior of the model after each interaction, but track also the behavior of our client as well. Okay, when it comes to that, GDPR will come into play. You will have to be very transparent about what you are doing with the data, etc., etc. But these are considerations that you need basically to have in mind before going live, basically. And based on that, of course, this is not the end of the story. You will need basically to iterate and go back, for example, to the design phase, maybe change the use case, change the model selection, decide to fine tune, and then do it constantly until it never ends. Basically, there is no end to this process. You will simply loop like this kind of for as long as, I will say, your company exists or your product exists. Okay, so the deployment stage address containerization. So I mentioned that comprehensive monitoring track, not just performance metric, but also drift and feedback from different category. Continuous improvement cycle. So of course, this is the MLOps basically methodology here. In terms of evaluation, so if you see here that at some point we will need to evaluate basically during the development the way our model is behaving. And in terms of evaluation, we have a huge list of evaluation metrics that we need to kind of keep track of. And here are a sample of some categories of what we will need to check to evaluate basically. We have functional capability, so measuring LLM's ability to perform specific tasks. So this means, for example, that we will have to design unit tests, because we can do unit tests with LLM, but we will design unit tests to make sure that for known answer or known or you will use, for example, your frequently asked question, and you will create unit tests on it to make sure that on very basic question the model always provide the answer that it is expected basically. You will also talking about the quality, so ensuring LLM meets high standard of excellence. So your company will kind of decide on the quality threshold and the level of detail basically that the model needs to perform, and you will constantly address and try to evaluate basically the quality of the answer that was provided. Of course, the safety is really important. So evaluating LLM adherence to safety protocol. So you will, for example, prevent using some prompt engineering technique, prevent you from the prompt injection attack, and you will kind of design the system prompt to handle some edge cases, like avoiding to use your chatbot for doing some random search over the net, for example. So you need basically, while you are developing, to think about some edge cases of your solution and make sure that you put something into place to avoid this. You have the performance metrics. You have the human feedback, so capturing subjective quality inside through the human feedback. So, for example, when you are working on the Chat GPT, uh, you can provide a feedback, but they are automatically getting some feedback from the way you interact, from the frequency you interact, etc., in order to find out specific use cases and decide maybe to innovate and create something new, for example. So you will not only gather what is provided basically by the user, but you will also gather, I will say, more automated stuff and decide or not, depending on if the law give you the right to use it. And of course, you will write your automatic testing. So of course, even with LLM, we have some automatic testing to make sure that we can just check that we didn't break something somewhere before actually moving further. So when it comes to evaluation, we have kind of a general framework that you could use. We have here 4 categories of evaluation that that is not a possibility that you will have basically to establish to implement. Of course, I mentioned the functional testing, so automating test suite, response validation, and regression testing. These are example of functional testing that you will need to code basically and make sure that you trigger them before doing something wrong. You have quality evaluation, so you will use the feedback, the subjective assessment, or use A/B testing to know the preference of your users. You have the performance metric. Of course, this is classic metric like the latency, throughput, the cost analysis, because I will say that when we start prototyping, most of the time we will use um, LLM provider API like OpenAI, Anthropic, Gemini, etc. And this costs because you have a token facturation basically, and you need also to pay attention to the amount of token that you are dealing with. And of course, this means that you need to have an active monitoring on the number of tokens of each request of each of your clients, and even detect when basically there is a peak and decide maybe to apply some restriction somewhere or decide to leverage to apply some scalability, etc. You have the safety testing, like the edge case identification to make sure that basically you cover the edge cases effectively. Adversarial simulation to make sure that to handle how your system will interact under attack, basically. And of course, establish, this is really important, especially for GDPR, establish some bias detection to make sure that you are not, I would say, propagating bias using your solution. So this is common, I will say, good sense in terms of software engineering. But in addition to classic one like performance metric and safety testing, you have basically the quality and the functional that will be more in depth basically when you are using LLM architecture. And when it comes to production, you can see that you will have a huge amount of things to take under consideration. Of course, I mentioned the scalability, so handling concurrent user, adapting to traffic like automatically. You have the cost management, so you need to have an active monitoring and maybe limit the number of token and implement some fallback mechanism that will, at a certain threshold, will, I don't know, use a cheaper model or maybe a local model if you are deploying a model on your server. You will have to think about latency. So, how many times do your client expect to have an answer? Basically, if you need some very low latency, you'll have to use some really powerful model with a huge server somewhere, or decide to pay a huge amount of bill, or maybe decide to do something different. And of course, the security aspect, like how the authentication, the authorization, the handling of sensitive data, and making sure that you are compliant with the GDPR, etc. Okay, so these are not, I will say, purely LLM related, but really important because, of course, you want to do something robust for production. So you need to have an answer to at least all this before saying, okay, I will go live and I will see what happens. So this means that you will have to implement, for example, some caching strategy. So the caching means that instead of constantly using your LLM to provide an answer to the same answer to the same question, you will cache like famous answer basically, and use your cache instead of the model itself when it is needed. So this will lower the latency and optimize also the cost. In terms of latency management, you have the response time optimization, or decide to do some batching. So this means that instead of handling 101 basically answer like this, you will decide to uh, handle batch of data instead of individual inputs, I will say. Or maybe you will decide to deploy your model on edge, like recently Apple Intelligence. So they decide basically that, okay, in order to reduce the latency at its maximum and improve the safety at its maximum, basically, we have basically a Mac infrastructure which can handle LLM. So we will simply deploy on edge. So this is a decision basically that can be made basically based on, I don't know, the infrastructure that you have in front of you. Of course, you have the security safeguard, so protecting against prompt injection and data exfiltration. So these are the things that the edge cases that you need to think of before moving to production. Of course, you have the privacy compliance, making sure that you will handle personal identifier information very efficiently. You make sure that you are compliant with the GDPR regarding data retention and other regulation that you may have to address basically, depending on the market that you want to work in. So these are simply a sample of production consideration. Of course, you will not uh, um, be very good at everything the first time. So when, at least when you are building your MVP, you will try to like address few of them, and maybe decide to deploy your architecture, your solution to a limited number of, of people, get more feedback, address other stuff before deciding basically to deploy like very broad. Okay, so this was in a kind of a rather long introduction about all this stuff about LLMOps methodology, and about the fact that it is really important when we are moving into production to have a lot of things into mind before actually deploying an application. And this will help me also stress the fact that this is precisely why I don't think that the LLM will replace jobs. Basically, LLM will only transform job. Like we have seen a transformation between MLOps and LLMOps, so we need to adapt. But you still need basically people that will have to think about all this stuff. Of course, at some point we'll have agent that will think of everything automatically and decide to do it or not. But LLM, the choices, the final choice should always be the human in the loop to make sure that everything is properly as need before actually moving forward. So I'm not sure. I don't think that the model will replace. It will surely change, and we need to adapt, but will not replace at all. Okay, so now moving back to moving further to LLM application architectural design pattern. So we have seen where we came from, the LLMOps methodology framework that we can apply, and then in terms of patterns, like specifically which pattern do we have? So I've curated a short list of well used basically architectural patterns that are out there. Um, and you can think of this pattern like building blocks, like I mentioned earlier. So like it's basically like you are playing with Lego, and you are simply selecting one pattern, combining, maybe extracting one part of a pattern and combining with another part of another pattern. But I'm simply giving you the pattern. Maybe one will be enough for your use case, or maybe two will be in combination be used for your use case. It's not like separately. You will have to adapt them. But these patterns have been kind of implemented and used by different company because they addressed frequent need like scalability, make sure that everything is reliable, and make sure that we are performant. Yeah, and that's it. So without further ado, let's introduce the first pattern. The first pattern is called, I called it the LLM provider architecture pattern. Yes, the name is very long, yeah. But the idea is simply that you will simply, this is the most simple one. You will simply use a LLM provider. The LLM provider on its own has already curated a data set, perform the training, and then create an API to use the model. So the LLM provider will be an OpenAI, any LLM provider that you can think of, basically. And you will simply kind of use the API within your application directly. So it could be a mobile, it could be a website, it could be very simple, I don't know, Python script that you are running, but you will simply, I will say, send the request to the LLM provider API and decide to use the answer or not. So this is the very simple one. So uh, we always start by this. I will say that most architecture will start this way. We'll simply use an API that is out there for simplicity. So this is rapid prototyping. This will bring rapid prototyping and MVP development. It will be very simple application with straightforward requirement. We simply need to know how the API works, to have a token, and that's it. We are ready to start. It is it is good. It is well suited for a limited budget project. Basically, you cannot just invest in a server or something like this. You will simply use an API which is out there within the logic of your application. But this application has some drawback also. First of all, the first one it is what is called the vendor lock-in. So when you have created the whole logic of your application based on the OpenAI API style, and some way, some later on you want to change the provider, you will have maybe to refactor maybe a huge amount of your code. So this could be a problem. And limited customization beyond prompt engineering. So of course you will use the API as the LLM provider provided. So cannot kind of you have some adaptation. The only adaptation that you have is through the parameters like the temperature, the top P, the top key, etc. But of course, most of the time you will not very much you will not too much play with the parameter itself, but you will work a lot on the prompt engineering and the system prompt, and that's it. Higher per token cost and high volume application. So yes, if you have a huge volume of data that you are using, of course, this will be there will be a good reflection on the bill basically when you are using this pattern, and it could be some problem with the latency because if I don't know OpenAI experience some amount of demand, you could have some error basically, and this could be frustrating for your end user. So I just give you the pro and the cons so that you can choose wisely. But this is the most simple architecture pattern that we have there. So to leverage the drawback, we can move to, I would say, the app provider architecture pattern. So it is almost like the previous one, but the only difference here is that between the LLM provider and let's say the end user, we will we will add basically an enterprise app provider. So it's basically like you are creating internally, I will say, your API. So your end user cannot directly send request to the LLM provider. It will first go through your API before actually being relayed to the LLM provider. And this is used for domain-specific application that require specialized user interaction. So maybe here you will not simply create a simple API, but you will apply some processing first some transformation, I don't know, that on the data before actually decide to use the LLM here. So here you can think of your application like you are decoupling basically the use of the API from the use of your end client. Your end client maybe will, I don't know, send some text, and based on the text you will simply use some part of the text with an LLM provider to do some stuff while doing with some other part something else. So you cannot just send directly the whole text to the LLM provider. You will adapt it here with the logic that you want to implement and use the LLM when you decided that the LLM was what's meant to be. So enterprise tools that need custom business logic or workflow, or when you need organization specific guardrail and control, application requiring consistent response in format. So these are all reasons why uh, that could justify basically to have this application in the middle, basically between your end user and the LLM provider. But of course, you have also drawbacks. You are still dependent on the LLM provider. So if you lose this one, your application won't work anymore. Limited control over the model training and the knowledge base. So because you will leverage the knowledge base of the model itself, so this could be a problem. Higher implementation complexity than the basic architecture because we have a middle piece here. It requires expertise in prompt engineering and LLM behavior to decide basically whether or not to call this LLM provider, but this is like the previous one. It can be challenging to maintain consistency across user experience. So you could have some challenges basically depending on the different, I will say, question or input that you have to basically translate it into your own rule and decide whether or not to use the LLM itself. But this is a pattern that is out there that some company maybe it's best for their needs. The other one is, I will say, the more challenging one. It is, I call it the fine-tuning architecture pattern, and you will use this when you want to create your own model because you have a specific need, basically. So you will have to your architecture will be much more complex because you will have to get data, apply some processing on it, maybe vectorize, so apply some knowledge graph or embedding on the data that you add, decide to fine tune your model and save the model and persist your model somewhere and keep track of the different version of your model. So basically, when you are doing this, you are kind of doing the MLOps, but on LLM, basically. And then when your model is ready, for example, you will wrap your model inside an API and then expose your API to your end user, basically. So of course, you will have to think about much more stuff like the model versioning, the model caching, and the model monitoring at the same time that you are getting the data and having a live architecture that never goes off, basically. So when this architecture will be interesting, domain-specific application requiring specialized knowledge. For example, I don't know, you are working for a for an hospital and you are working with some specific expert on, I don't know, a rare disease somewhere. You cannot just use the broad knowledge of a software or something which is not all, I would say, not known as we speak. So you will need basically to fine tune. So fine tuning means that you will need to adapt a model that is out there to a specific case of some data that you have, and also to have a specific behavior. So fine tuning could be really, really interesting when you want to, because even with system prompt, you can have some drift when it comes to the LLM behavior. But with fine tuning, this kind of reduces to zero because the model will be kind of adapt to a specific behavior specifically to your need. So we will use this when consistent output format and style are critical because you will train your model to always deliver output on a certain way and you in a certain manner as well. scenario with specific technology or jargon requirement, like in medical or in law, for example. If you are working for a law company, for example, the law has some jargon that are used, and will decide to train a model on that. And this will also be useful for security aspect, because since you are creating your own model, you can do it on your own server, on premise, without connection to internet, and this is for security maybe the most interesting. Okay, so in terms of drawback, you have this require domain specific training data collection curation. So you will need teams of engineer in order to do so. Data scientists, machine learning engineer, the whole thing. You will need the whole team, very basically. Uh, Significant technical expertise, because of course you are not just training on your own. You will need to discuss with experts, so that they can validate what is done, the methodology, the interpretation, and a lot of things. So yes, you will have to put in place huge teams, if you want to do it seriously. And since you want to train your model on your own, you will need a complex infrastructure. You will need a databases for the data, compute power for the training, and of course, where to save the model, etc., etc. I'm not even talking about this API server or the model registry or the or the feature store. Yes, you will have the kind of the most complex infrastructure out there, and this is maybe why not all company will start this way. You will start fine tuning architecture when you are really mature with the way you are doing data science at all, the way you are doing the data engineering, the way you are using the LLM. You are starting to understand specifically what you want. You know the techniques, and you have the expertise in your own area, and you decide only to combine all this to have to create something. So this is a so only today, only I will say LLM provider has this capability, because they have the teams, they have the mean, like Google recently that released the Gemini 2.5. Yeah, they prove that they have everything. They cannot rely on other or maybe a cloud provider for the compute, or someone else. They have the teams, they have the infrastructure. They can simply and they have access to the data, because of course they are Google. So they can simply just leverage all this and create the most advanced model if they want. Okay, so this is the fine tuning one, and the last one that I will share with you is the RAG architecture pattern. We are specifically doing RAG when we don't want to fine tune, but we want to use our own data basically in the loop. And because if you are using LLM, you know that when you are not using your own data, you have hallucination, and this could be catastrophic for your company. So that you have some data, some internal data that you want to always keep private, and you want to use the power of the LLM basically to simply, I will say, reason over this data. So this means that you will you will have, of course, to save your data somewhere, but use the LLM provider that will simply retrieve your data and decide to use a piece of your data, embed it into the prompt itself, and have the model kind of formulate an answer based on that. So you will have to implement what is called the RAG methodology. RAG stands for retrieval augmented generation. So this means that you will have to, because LM cannot just, you are probably aware of what is called um, the contextual knowledge. You cannot just put everything within the memory of the model. It is precisely then that the model starts hallucinating or forgetting stuff. So you want to include only the necessary piece of information into the memory of the model, so that the model can, based on his knowledge, adapt on it using the prompt engineering. So this is why we are using RAG, because RAG will consist first on retrieving the most important piece of information, and then augment it into the LLM knowledge, basically to provide a precise answer, basically. So this is why you have You will use a cloud provider through the API, for example, but you will combine the LLM provider API with your internal knowledge, and you will have to implement some document search. So this means this will bring new technologies into your architecture, like a vector database, in combination to API or from a cloud provider, and decide basically to answer a need. So the classic example of this is you want to create a chatbot that will give information about your product, and you have in your company a database with your product information, and you don't want, of course, that the model creates something that doesn't exist. So you want to use the LLM but connect it with your knowledge so that the model will provide the knowledge basically that you already have in the company. The drawback of this architecture, so this increased latency because you need to retrieve the information before passing it to the model through the prompt engineering before having the answer. So in terms of latency, you can, depending on the amount of data that you have, this could take some time if you don't have like the compute that comes with it. Um, Quality heavily dependent on document corpus. So if your document is not properly curated, well structured, etc., be some challenges with it, with the retrieval aspect. Um, the retrieval accuracy challenge is a challenge on its own because studies have proved that even if you have the data, you still need there are edge cases when the model cannot find like the precise data that is needed for the question. So we have RAG on its own. We can talk only on RAG about on 4 hours and even more, because you have huge, you have paper research paper on only on RAG, and you have lots of different techniques basically to make sure that we are retrieving the good piece of information. So this is a challenge on its own basically, but this is a classic pattern that you can find out there. Finally, the last one, and this is really the last one, it is the agent architecture pattern. So with the agentic architecture, basically, it means that you have an agent. This is what I call here a kind of an enterprise integration and orchestrator, and you will connect to this orchestrator an LLM and different tools, and this orchestrator will decide based on the user query to use either of these tools like autonomously, basically. So you will not program the model to first use this and then and that. The user will simply provide the query and have an answer. And behind the scene, the agent basically will work to identify the intent of the question, detect the tool that needs to be used, use the tool, retrieve the answer, reason on that, and decide to provide the answer or not. So you can see that this is, if you had to code it by hand, you can do it, but you will not cover the different cases basically. So we need some flexibility. We don't want to code all the code, but we want something which is really robust. This is the most basically, and this is where the innovation is today. Most of LLM provider behind the hood have some agent. So when you are on ChatGPT and you are saying something like, "What is the current weather around Paris?" The answer will not. The LLM won't be used directly. There will be first a research over the net, then the data will be passed to an LLM, and then you will have the answer. And to have this, you need to have an agentic architecture to leverage tools basically before providing an answer. So when we use it for domain-specific application requiring specialized application requiring complex multi-step task. So complex multi-step means that you don't have a list of steps. You don't actually know the step basically. You simply know that to answer this, you need to use, I don't know, a calculator, a web browser, a web search, and then combine it. But you don't know exactly the right order, and that's it. Workflow needing coordination between different AI model, because in the agentic architecture, you can use and you can leverage the use of different LLM, not only one, but two, three, and four. and have some specialized LLM depending on what you want to to do. Enterprise system with multiple data sources. Of course, if you have not only one database but two or three, a data mart, a data warehouse, etc., and of course, you want you taking the time to code basically the logic under which each database will be used will be like overkill. You will simply leave it to an agent to find out where the data is, which database to use, which query to run, and decide to work with it or not. But of course, also this architecture has some drawback. Its highest implementation complexity because you need to know about agent framework and use it properly. This also has an impact on the latency because you will kind of leave some time for the agent to work to do its thing. More challenging to debug because the model could have different interaction with different tools and not in the order you will expect. So you will need to have a clear monitoring about it. And when something fails, of course, this could be challenging because you need to find out where exactly which tool didn't work or which model didn't respond properly, etc. So there are some challenges of this, but today it is the most advanced one. So for all these reasons, we will need some framework basically to build all this. And this is where precisely we will use framework like LangGraph. It's basically an ecosystem. In the ecosystem, you have LangChain, LangGraph, and Langsmith. And sometimes we will combine three of them for a use case. Of course, LangGraph is not the only one. You have lots of different framework. But before talking about LangGraph, I wanted to make sure that everyone is on board with what is an agent precisely, because I talked a lot about agent, but I want to just to have a clear idea about what an agent is. Basically, an agent is like a smart assistant that make decision, it take action on its own. So without having to say one do this, it's not a chain of thought. Basically, it's a you will give the agent general rule, and the agent will have to iterate on its own and find out the right path. But the idea is basically like you are connecting to imagine giving an LLM not just the ability to respond but to question, but also tools to look up information and run calculations. So it's basically like take an LLM, you add the possibility to think. So thinking is basically to the model could ask question could raise another question from the question that you ask, and at the same time you connect this LLM to different tools, and combining all this give basically what is an agent. So in the agent which is here, we have a thinking component which is which has been given to the model after the fine tuning basically, and then we connect this model to some tools, and we associate this is optional here, but in most advanced use case, of course, we will associate the agent to a memory so that the model could keep track of what is going on basically while it's going on. So this is why that not all the model could be used for agentic architecture. For example, if you go over, I don't know, the Olama platform, you will see model with the tool tag. So these are models that you could use for agentic architecture. And for example, even on OpenAI, the 4.0 could sometimes you the most the good choices to create an agent architecture will be the O1, because the O1 during the fine tuning are already has this capability basically to take a question, raise different sub question, for example, and then iterate on each of these questions based on the tools, and before actually decide to provide an answer on that. So this is basically an agent. So an agent is a compilation of, I will say, different things. Of course, you have the LLM. The LLM needs to have some thinking capability, and then you connect different tools and you include the memory, and then you end up with agent. Okay, now when we are working with agent, of course, we have different agent pattern that we can use. So previously I talked about general architecture level. So I was talking about broadly general architecture. And now when we decide to use LLM, we have kind of different um, ways of using an agent. You have the router pattern, structure output pattern, self-reflection pattern, React pattern, and RAG pattern. Can by the name already understand basically which pattern will be used for in different cases. If you, for example, need you can see here that the React pattern is ideal for tasks requiring sequential reasoning and action. So you will use a React pattern, basically agent that will has which has these capabilities basically of thinking sequentially with methodology, with in combination with extracting using external knowledge or maybe code execution also. So this is the React pattern. Or if you the task is really complex that requires some deep analysis before actually finalizing an answer, you will maybe go for a self-reflection pattern, because the self-reflection will so use when technical details and intricate and error prone. So you will simply need to think first, analyze the answer, then improve the answer, and think again with a certain depth until you reach the point that okay, I find out the good answer and provide it to him. Basically, DeepSeek, for example, could be very good for this, and the O1 also, and the later Gemini 2.5 also. You have the structure output pattern, but this is when you want to integrate your agent with some other software tools. Because when you want to integrate your agent into a broader ecosystem, you need some communication. You need to present the output a certain way. So you will need to structure the output, maybe in form of JSON, to make sure that the next piece of tool will pick up the right format in order to work with it. So use it when yes, the next piece of tool will need a specific format in a specific way, basically, in order to work with it. And of course, you have the router one. The router one is basically so classify question by topic and complexity, directing them to specialized components. So it's basically like a general. It's a manager basically. It's basically it's as an agent manager that will first try to understand what is required based on the question, and then send basically some tasks to do to different other tools or even different other LLMs as well. So generally in some architecture you have the entry point will be a router pattern, and then later on we can maybe leverage a self-reflection and then combine it, let's say, I don't know, to a calculator, let's say, or a web browser before actually providing an answer. So once again, these agent patterns are not mutually exclusive. You can combine them or chain them as you see fit. These are simply the different main ones that exist, and based on your need, basically, you will select what is the most useful for you. So in this ecosystem, now I can properly introduce what is LangGraph. So LangGraph is simply a framework like LangChain itself that helps building the agent, basically. So the different pattern that you have presented earlier can be created with LangGraph. Of course, in LangChain, you have some agent function that are already pre-configured, basically. You simply need to import them and use them right away. But LangGraph gives some flexibility, more flexibility, and a bit more control, basically, on the flow of the way the agent is working, basically. So LangGraph, you define, so with LangGraph, you define different states. Your agent can be like in the thinking, in searching, and answering. So these are the states through it toward through which the agent will go through. And you will also and the rules for moving between states. So you will have states that will be automatically managed by the framework. So the agent will move from one state to another, and for moving to one step to another, you will follow the rules basically that you define. So this gives a bit more control basically to the different workflow basically that you want to establish. So the magic of LangGraph is that it lets your agent follow different paths depending on the situation. So you don't code the path. You simply describe the logic. So it's meaning, okay, to between this step and this step, this is the rule, and that's it. And the agent will, on its own, find out if this needs to be followed or not at all, basically. And the difference with the LangChain is that with LangChain, which is the other framework created by the same creator, basically, in LangChain, everything is kind of sequential. So you need to think about the different steps and code them like precisely. But the problem arises when things start to be a bit complex. There could be different paths to the same output, for example, and you don't precisely have time basically to code all the chains basically. So you will simply use LangGraph basically, defining the states, defining the rules between successive steps, and then you will leave the agent basically follow its own path completely. The core concept within LangGraph, we have we will work with nodes, basically self-contained unit of computation. So we have nodes basically. A node is like a precise step on which the agent is. Between nodes, you will have ages. When the agent is being kind of is being loaded, I will say during the execution, LangGraph manage the state. There is a state management, so it's a unified context that evolves through the graph execution. So LangGraph use the graph theory behind the scene to kind of more, I will say, more visually see the workflow and automatically record basically in which state each node and the agent is basically. And between the node, basically, you can even implement some conditional logic to to yes implement not like a straightforward logic, but a conditional logic. So you can kind of build a graph, a decision tree, I will say, and decide to let the model follow a path that is that it's it fits. Dynamic workflow, so ability to implement loops, recursion, and complex decisions. So it's very flexible. It's basically like you are visually programming, but you are not specifically saying from A to Z what needs to be done in order to answer a query. You create the path, the tree, and you leave the model, the agent, decide basically on the branch, or maybe follow separated branch, or at the same time, it's the model that will decide basically to do so. So this is why LangGraph is really powerful nowadays. And of course, this is not the only one. You have other framework out there like Crew AI, like AutoGen of Microsoft. OpenAI even created their own agentic framework. So nowadays, basically, yeah, everyone is kind of building. But the Lang, I will say the Lang ecosystem is well established nowadays because LangChain was kind of the first to think about this way of integrating piece of LLMs with software. And so this means that the teams behind LangChain, LangGraph, etc., are kind of well established in the domain. Yeah, LangGraph for production application. Of course, with LangGraph, we have some additional capabilities, like you have an automatic observability. So you have a tracing tool and a real-time visualization that you can visualize the states basically of your graph as the agent is executing itself, basically. So this is really interesting to see exactly how the model is following path exactly. You have error handling. Yeah, so in code you can very much more efficiently implement like fallback path or graceful degradation. So making sure that if I don't know some path is not successful, that you handle this with care. State management, so multi-turn conversation and state persistence. So there is a persistence of the state. So you can it's very efficient as debugging. So when you are executing your graph, basically, you can continue from the last successful node, for example, instead of rerunning like the whole logic each time that you are debugging. So this is really powerful also, and there is also the testing capability to make sure that we can apply some unit testing on anything on the graph, and even integration testing also. So this is really interesting, and it had been built to be modular like LangChain, so you can combine and like you want. And yes, the operational monitoring, so track performance metric per node for targeted optimization automatically. So you simply need to get access to the logs and then find out what you need to do. In the ecosystem, so I've talked about LangChain, LangGraph. In the ecosystem, you have Langsmith, which is dedicated for observability. So I mentioned the fact that when you deploy a model, you want to constantly know what is happening in your architecture in order to decide to do something else or to change something. And of course, you can use MLflow, because recently MLflow upgraded, and now you can have some traces and some level of I will say monitoring in MLflow when you are working with LLMs. You have also weight and bias that can do the same thing. You have something which is called LangFuse that can do the same thing. Yeah, you have lots of different framework, but the good idea here is that when you are using the ecosystem, they have been thought to be like really easily integrated. So when for example, I want to use Langsmith, I don't need basically to install a lot of you. As soon as I'm using LangChain, simply need basically to forward any execution information to the Langsmith API, and that out of the box like this, I have an implementation of observability. I don't need basically some new tools that I need basically to configure. So yes, there is some configuration level, but not the amount of using something really different from the ecosystem. So I will show you the Langsmith in a minute, but before actually moving to the demonstration, maybe you have some questions into the chat. I will leave you a few minutes. If you have question. And maybe not. Okay, so let's move then to the demo that I prepared today. So I created a very simple thing. The idea is to create a Python tutoring application. It's basically like my idea is like you have a simplified front end where you can just ask question, very simple question, very simple Python question to this front end. And behind the scene, the idea is to have a agent that will try to first understand basically what is the question and decide to maybe directly answer the question, or decide, for example, let's say that a user will say, okay, I want to create a function that, I don't know, list the prime number, or I don't know, sum up two numbers. And so the model, what I use in agent is that I want the capability not only to write the code, but also to execute the code and to provide the final answer with. So yes, I've already prepared it, so I won't bother you with all the detail. I will show you just really the code real quick, and show you how to kind of use it. How to use it. Yes, I'm looking into the chat. Yes, so we are live. So later on, the video will be recorded. So of course, you will retrieve it on the DataScientest YouTube channel. Yeah. Okay, so I will now stop the screen and share. Maybe I will share the whole screen because I will show you a few things. Sharing the window. Yes, and then okay. Okay, so now okay, this is a bit. I will close this and reduce this a bit. Maybe if it has this. Okay, I hope that this will be wide enough. So the first thing that I wanted to explain is basically how we go from the ID until the actually architecture that I put behind this. So we want we want to develop basically a Python tutor agent. So um, the first thing that of course you will have to do. I'm not coding here. I'm simply kind of properly framing what I want to do exactly. So the objective is to create an AI assistant that can help users learn Python, basically. So now I'll give a bit more detail because this is kind of too broad. And of course, in real life scenario, you will have to you will have to of course discuss with the teams and the client and yeah decide which precisely need to be developed. But here my idea is this agent needs to answering general Python question, executing user provided Python code snippet. So the user can pass the code and say execute it and provide me the answer. Explaining the code, execution, and any error that was raised, and providing conceptual explanation related to code or question. So we are working with Python, and the idea is simply that you have an agent, you can pass the code, ask the model to explain the code, yeah, like a Python tutor, basically. So this is the first step. I'm simply precising, simply being a bit more specific about exactly what I want to build. Second step, I will initial architecture consideration. So I'm simply thinking about precisely how what are the end product basically of what I want to build. So based on the core goal mentioned earlier, so several architecture components I've identified several ones. So first of all, since I want the agent to interact with people, basically, I need to create a web interface, a very simplified one. So needed for user interaction because this is the end thing that my user will want. LLM interaction. So the core intelligence require interaction with the large language model. So of course, I will need to pick an LLM for that. Since the user can execute some code, I want to provide a possibility to execute the code. So I need a running in my architecture. I need to have something that will be able to execute the code. So running arbitrary user code require a secure, isolated environment. So of course, I don't want that if the user provide the code, I execute the code directly on the same server where my application is running. It's basically like I'm just sending the code to some tool that will execute the code and provide me with the output, and then provide the LLM with the output, and then the agent will decide to work with it or not. Since we are talking about Python, the idea also is that if let's say we are a training center, we want to I don't know deploy this, we need to have a knowledge base. We have a knowledge base like courses, blog posts, or anything that you can think of that the agent could get access to in order to retrieve some answer and then provide them directly to the end user. And then of course we will need orchestration in order to like leverage the code execution environment or the knowledge base based on the question that was provided. Okay, so now this is simply like a broad overview of my architecture. Now, more specifically about the technology. So for the app service, I use Fast API with a simplified HTML front end, basically, that are launched through the Fast API. I could have done this with Flask, with Streamlit, with Fast API. with fast HTML, which is another framework that is kind of booming right now. But yeah, for simplicity, fast API with HTML. That's it. Now, since I want to run it on my local machine, I don't want to execute all this code and all this in a like directly in my terminal. I want to use Docker for that. So I will need to create a microservice architecture with Docker and Docker Compose. Um, and especially for code execution, because I don't want to execute in a not in my own computer so that I could maybe destroy something or erase something. So I need a kind of a sandbox where the code will be executed and simply send the result back. And since I'm working with Docker Compose, defining and running multi-container applications, so this is why I'm using Docker Compose, because I'm locally, of course, in production. I could move to, I don't know, technology like Kubernetes to do so at scale, etc. But since I'm prototyping only and I'm building my MVP, I'm stick with Docker Compose. Okay. Now for the LLM, this is where it gets interesting, because I could have simply embed the open on I could have simply embed a LLM provider directly in my code, but this is actually not a good practice, because for the reason I mentioned earlier, if you change the LLM provider, you change the whole code all the time. So I leverage something which is called light LLM, which is really interesting, because it's basically like I'm following the app pattern that I showed earlier. So I will use the LLM provider, but I will use a kind of a proxy, a LLM proxy that will first the prompt will go through this proxy before actually going to the LLM provider. And the good thing about light LLM is that you can keep your code base the same, and you will simply have to configure basically using the LLM proxy which model will be used. So you can list different model. For this demonstration, I used Gemini, basically the 2.0 Flash, because it's very fast. But in the LLM proxy, I can embed basically an Anthropic, an OpenAI, or any other LLM provider, but my code will remain the same, because my code is interacting with with the LLM proxy, and it is the LLM proxy that forward basically the answer the prompt basically to the LLM provider. The other good thing about light LLM is that you can is really powerful, because you can implement some prompt caching with that. You can implement some level of security also here before actually forwarding the answer, etc., etc. So you have lots of capability. So allowing easy switching between model. We centralizing API key management also. So basically, you can think of it like if you are in a company, and that you can probably work with different LLM at all. Your employee doesn't need, basically, if you are using, I don't know, Gemini, OpenAI, etc. They simply will uh, send the request to a proxy, and it is a proxy that has all the knowledge about which LM it uses, etc. Okay, and yes, this is also to avoid the vendor locking thing, so I can switch to the LLM provider very easily without having to change my code base. Things I also want to leverage some document that the company might have, so I need a vector database. So for my choice, I'm working with ChromaDB, which because it's very simple to use. But you have alternative and like Pinecode, Weaviate, Face from Facebook. Yeah, you have lots of different other choices out there. So think of this vector database like a database that will have all the knowledge, all my internal knowledge about Python, for example, my courses, etc., etc., and the agent will use this. And then, yeah, I mentioned the fact that the secure code executor. So I will create a specific tool, basically, a specific service where the sole responsibility will be to run code, and that's it. And it is in the isolated Docker environment. So this means that even if the user send whatever request, basically, it doesn't matter because it's in an isolated environment. So okay, so this is a good practice here. So now this is my technology selection. Now about the architectural pattern. So I'm moving back now. Now I know what I want to do. I selected my tool with some good reason explaining here. And now how am I going to combine all this? So first of all, I will be microservice because yeah, I want to be flexible, apply scale at different services, etc. Microservice. API gateway pattern. So instead of directly sending my request to the LLM provider, I'm using a API gateway, which is my light LLM service that will relay the prompt to my to the provider that I'm working with. Yes, and of course, yes, these are best practice. Never to embed, of course, API key, etc. within the code. So I'm leveraging environment variable using a .env file to keep the token, etc., the identification, etc. And of course, yeah, for the code executor, I have something which is Dockerized. So this is basically the general idea about the architecture. We will have the end user here. The end user will interact with my front end, which runs through a fast API. Based on the query here, the query will be passed to LangGraph, and the LangGraph agent will leverage basically the tool that I'm connected with it. So if we need to execute the code, it will execute here. If we need to retrieve something from the knowledge base, it will use here. And if it needs to, based on the result of that, it will then go through the proxy to interact with Gemini. Yes, and for the agent pattern selected here, yeah, I've combined a bit few patterns that we have seen. The basic problem, so code and versus knowledge. So the agent needs to differentiate between a request and a request for a request of running a script or or just answering a question. So I use the pattern router, if you remember, because since I have some different use cases, I need to identify what is the intent before actually activating a tool or not. I combine the router with the React pattern because as soon as a tool have been used, I want the agent to identify the code, send the code to the executor, get the result, interpret the result, and then finalize, and then send back. So I implemented the React as well. And since I want to use my knowledge base here, I've also implemented the RAG pattern because this is another tool basically to retrieve only the data which is in my database. I didn't do the structure output because of course this is simply interaction. I have an answer, but I have an answer and I provide I have a query and I provide an answer. The simple thing that I did here is simply to ask basically the LLM to have a clear structure in the way they are writing the answer, like explaining the code, the result of the execution, the error if we had some error, etc., etc. Okay, formation. All data are available to the LLM, or the LLM write a query to take only the part of the LLM only retrieve through the ChromaDB the precise knowledge that it needs to know. Basically, when you ask a question, the agent will detect, for example, that okay, this is a question that might be in the knowledge base. So it will ask the knowledge base. The knowledge base will then kind of select basically all the piece of information that will be related to my question. This piece of information will be passed to the model, and the model will formalize an answer based on that. And then, yeah, just for playing, I've implement also a special case like for query like what is 2 plus 2 or what is the root square of 16, etc., etc. Just to make sure that, yeah, for a very simple question like this, that the model will leverage the code execution tool to use some Python script, execute, and then get the result and then provide it back. And then to tie everything up, of course, I use LangGraph because for the modularity. So I've defined a different node basically, and of course, I didn't do it, but it is possible to it is possible to have a visualization basically of the graph that was created. But basically, the agent flow logic is like this: you have the user query. First, we have a routing basically to decide which is the branch that will be followed based on the flow. For example, if the answer could be directly answered, this is will I will simply call a function that will use the proxy basically to provide an answer. If the model asks for some clarification, for example, I have a dedicated function for that. If the user, if in the intent we need some execution, basically, we will use the execution tool that will be passed to the LLM and then provide an answer. And if we need basically to retrieve the answer from the knowledge base, basically, the knowledge base will be used. And the good thing about LangGraph is that if for a STEM question we need to retrieve and execute a tool, LangGraph will follow both and then formalize an answer. So this is the strength of LangGraph is that you simply define basically the different node basically and the different rule, and based on the query, the path follow is completely kind of different each time. Okay, so now for that, so implementation. So I won't bother you with all the technical aspect, but I can simply just show you a bit the code structure here. I have the app folder where I have my main API and my in template I have my front end basically, and I have the code of my agent. So all this will be in my main application, but I could kind of divide them for simplicity. I keep them the same place. I have my application. I have my code executor, which will come with a Docker file and then in a script to be able to execute some script within my Docker container. Here you will find this is the initialization of my Chroma DB because I run it to test it just before the this session. So before when you start from scratch, you have it is empty. It is only when you execute it the first time that you can see some data that appear here. So here is simply my documentation, basically the stuff that I've written exactly. I have some test case because, of course, since I'm microservice, since my application, I have a front end, but since I have an API, so this means that I can send query requests to my API and pass some requests, basically. So I have two ways, basically, of using my app. I can use it from the front end, or I can use it programmatically, basically. And talking about Light LLM, when you are working with Light LLM, of course, you will there is the Light LLM Docker image, but you have a config file basically, and this is where you will specify basically the configuration. So here I can list different model here. I'm using Gemini Flash, and I can implement some settings like the timeout, and I can do even more than that. This is basically the bare minimum, but Light LLM has huge list of parameters that you can use for caching, for a lot of stuff. Okay, so now this and just showing you basically the Docker Compose. You can see that it's not very long at all. I'm building from my Docker file, basically. That's it. I'm passing some parameter, and since I want to integrate my architecture with Langsmith, the only thing that I need to do is this. So I'm passing this environment variable. I'm simply pointing to the LangSmith API. Basically, that's the only thing. And I'm retrieving yes from my .env here my key from LangSmith, etc. I have my ChromaDB for my knowledge base. I have my code executor for executing my code, and I have my light LLM proxy server where I'm yes passing some parameter, etc. to run my server basically. So as you can see, not that much complicated. So now running the thing. Okay, so very simple as Docker Compose up. I've already launched it first, so it will um, it will normally build very rapidly. Yes, it's already done. Yes, one just final thing before moving to the app side here, and I know it's very simple then. So yeah. No, it's not there. Okay, now you can see that my this is my my Docker desktop view, and then you can see that I have my app running, I have my light LLM, my ChromaDB, and my code executor, which are waiting. So if I'm entering each one, so you can see that yes, it detected that I have already a knowledge base basically, but the first time that it is run, you will not have it. I have my light LLM server, which is running perfectly and waiting for any request. I have my ChromaDB, and we can see that, yeah, this is for the initialization, and my code executor also, which is running fine. And then I can open my, okay, I open it on the wrong screen. Okay. Okay, so yes, once again, yes, maybe this will be, yeah. So this is the front end basically, and yeah, I can say, okay, maybe I prepared also few testing case. So no, it is my dogs in testing. Yes, this, and that. Okay, so I'm running. So I'm starting just with a very simple thing like um, um, pasting this. So what is Python for, basically? So here you can see that it provides an answer to Python, virtual shell, etc., etc. So you have just an explanation, and now just to show you that everything is recorded on the LangSmith. So for testing, I've already launched it first, so you can see that this is the question that I just launched basically. So yeah, this one. We can see that when at launch, the ChromaDB was initialized. So this is the first trace that we have. And we can see that on LangGraph, we can see all the trace of what happened behind the scene. So we entered the root, then we did, based on the query, the agent decided that, okay, it is the retrieval knowledge that needs to be addressed. Knowledge have been retrieved, and then the answer have been provided to the LLM, and then we have an answer. I can show you like the waterfall of this view. Like this. Yes, it's maybe, yeah, and you have like the input and the output, which is shown here. So this is LangSmith. Basically, you have all the interaction that goes on, and even all the interaction that the agent basically is following. Basically, okay. So this is that, and let's try out something like this. Like, can you write a Python function to find a prime number? Okay, just that. Okay, this is the demo effect. So sorry, that was an error processing request. So I will send it back, hoping that it will work. because since I'm using a free API, that is challenging. But yeah, for debugging, yeah, I can just move back here. I can see that the request, so calling LLM using LLM light service, etc. So I can go for light LLM. So everything seems to be fine. Okay, maybe I will try a different. It worked previously. Okay, maybe I will try this. Okay, so okay, so so can you fix this? So I have the explanation, I have the code analysis, the original code for print results. So this means, for example, that the code was executed, it generated an error, and then it provided this, and then it give you basically an idea of the answer and give you best practices and etc. So moving to Langsmith to know what happened behind the scene. Um, I need just to find, I believe it's this one. So as you can see, um, so I need to first I need to fix something because it seems like I keep having the whole history here. So I definitely will find a way basically to fix this. But we can see that based on the latest, the last request that we have, we had the routing. The code was executed, and then the answer was provided, etc. So this is why you can see that um, with the code, he executed the code, got the error, and then provided an answer, and then giving you the LLS. So all this is made because now I can show you the agent, and I will mask this. Okay, this code is kind of monolithic as its own, but yeah, just bear with me as I wanted to do something very easy to do, like very fast. Um, I have different function for logging from some Python in class, different function that will kind of so this is no more use at all. Basically, I'm just keeping it. Just I started prototyping with it, but I used a light LLM after that. No, not no. This is okay. Yes, I'm using LangChain, LangMist. Okay. I have my function called LLM that will simply send the request to light LLM proxy, and I'm sending some JSON parameter as well. By the way, this is best practice. I should have this in a config file somewhere. Okay, don't do it. Okay, this is simply my function to forward the answer to my light LLM. Road query. So this is the the function that will perform to decide which path to follow. Basically, I'm getting the state basically, and based on some keyword, the code will simply detect which path needs to be followed. You will have the code, so you will dig deep into it. So refactoring, execute the code. So this in my app, I simply have function that will either apply a logic on my LangGraph or send the request basically to the code to other service. So all this is simply to detect some pattern. For example, sometimes someone will write run or calculate or compute, that all these pattern basically will help the model basically to identify in which scenario the execution code will be performed. But I will just show you because the LangGraph basically code is basically at the end, and you will see that it's not that complicated. So I have my agent. So this is all my agent. The agent first will decide the step. Then it will, based on the state, I added some nodes. So I have the node root query execute. So all the functions I mentioned earlier, these are the function that will be executed when the agent will be at this node. Then I have the entry point, basically. What is the first entry point? And add conditional age. So this is the functionality of LangGraph. I'm adding a condition basically to switch between all this depending on the context. And add conditional age, either to generate an endpoint or to end, basically. I'm adding conditional age as well to because why I have this in double. Okay, no, this is for retrieval knowledge, and this is for executing the code. So this is conditional knowledge. And then I'm simply adding a name, basically, because since when the answer will be provided, I will decide to end and then just compile the whole thing. So the whole agent logic is just few lines of code. The other code are simply function that will be executed in my agent. And that's it. So as you can see, not that complicated at all. I have simply that agent, and you have the Docker Compose and the Docker file, Docker Compose up, and you can see that. Let's move to I don't know, the app. You can see that you can also retrieve also the logging of everything that goes on, basically. So you have the request, you have the generating response, calling LLM, routing, executing code. So even in logs, even if I'm not using LangMist, I have some level of detail that's happening behind the scene. So I can decide basically to debug a bit, and I can go into this one to okay, this one is not showing anything. I can go into each service basically one by one to see if the request was performed or not. Okay, so that's a small demonstration I used basically. I can check the question. So yeah, will you mind sharing your project, or is it available? Or yeah, I believe I'm, I'm not sure basically that um, yes, it is on GitHub. It is on public. Yes, so you have the whole code here. I will provide it later on. I need some fix to perform, but I will provide the whole code once done. And yeah, you will have all the code in the repo with the documentation and everything. And of course, yes, this is recorded as well. Yeah, you have you will find it later on YouTube. So does the workflow of decision could be trapped in a loop? Yes, I didn't cover everything. Of course, I didn't test anything yet, so I'm not. I cannot say this application is really not good. Basically, right now for production, I need to address more edge cases. So I need to test it more, like more in depth, basically to make sure that I didn't forget something. I simply wanted something really easy, like a prototype. And now this is an MVP basically. And the thing that I need just to strengthen here is to implement security, more security stuff, because anyone that launch it without token and anything could just use it. Maybe I will add more LLM provider. Maybe decide to use Olama as well. So this could be interesting to do. And yeah, and in the logic of the agent, yeah, definitely there will something that needs to be done. Okay, so that's it for today. All good thing comes to an end. Um, if you have few questions, you can just uh, run them into the chat. Other than that, I will thank you for attending this webinar. I hope that was interesting at some point. I will just finalize the code, provide the slide to the communication team. So normally they will add it into the comment on the recording on YouTube, and that's it for today. Okay, thank you guys, thank you everyone, and have a good day, basically. Thank you, Philippe. Yes, the repo, the link. Yes, you will have it with the slide in the comment of the video. Yes, there is a lot more to cover about it. I just simply wanted to give you like the broad idea. Now of course, we can dig more deep into LLMOps, maybe creating more advanced agentic software, etc. So definitely, yeah, I will think about it for next developments. Okay, guys, thank you very much. That was interesting. You will have the resource, you will have the recording, and maybe see you soon in one of our training.